Okay, I'm going to go over your notes. This is going to be solving by factoring. So we're going to solve trig equations by factoring. I might be talking fast, so if you have to, please slow down the video or pause. All right, so number 7. So 4 cosine squared x minus 1 equals 0. If you notice, this is a difference of squares. So you can take the square root of the first term and the square root of the second term. And then it's going to be, if this is a squared minus b squared, this is a plus b, and then a minus b. All right. So here, the square root of 4 cosine squared x would just be 2 cosine x. And here, this is going to be the same thing, 2 cosine x. And then the square root of 1 is just 1. So it's 2 cosine x plus 1 and 2 cosine x minus 1. And that is all equal to 0. Well, because of the zero product property, I can set both of these terms equal to 0. Right? So it'll be 2 cosine x plus 1 equals 0. And 2 cosine x minus 1 equals 0. Well, we would solve for x, so we would subtract 1 and then divide by 2. So it'll be cosine x equals negative 1/2. And over here, we would add 1 and divide by 2, so it'd be cosine x equals positive 1/2. So we want cosine x to be negative 1/2. So if we look somewhere on the unit circle, for it to be negative 1/2, it would be at 2 pi over 3 and 4 pi over 3. So 2 pi over 3 and 4 pi over 3. And then for positive 1/2, cosine x to be positive 1/2 would be at pi over 3, and then directly under it would be 5 pi over 3. Sorry about that. So my solutions, since our domain is from 0 to 2 pi, it's going to include all 4. So x is equal to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, let's go to number 8. So number 8. So here there's different ways you can actually do this. What I'm going to do is I'm going to divide both sides by cotangent. Right, so I'm going to divide this by cotangent x and this by cotangent x. Here, these will divide out to be 1. And then cotangent over cotangent divides out, so I'm left with sine squared x. All right. So here, I can subtract 1 from both sides. So I can get 0 equals sine squared x minus 1. And then you take the difference of squares. So this will turn into sine x plus 1 and sine x minus 1. And we split these up to both equal 0. So sine of x equals, or plus 1 equals 0. And then sine of x minus 1 equals 0. So in reality, I would subtract 1, so it'd be sine of x equal to negative 1, and then sine of x equal to positive 1. So sine of x is equal to negative 1 at 3 pi over 2. And sine of x is equal to positive 1 at pi over 2. But let's look at our domain. Now, our domain is from pi to 2 pi, right? So on the unit circle, that would be from pi all the way down to 2 pi. So just the bottom half. And pi over 2 is on the top half, so 3 pi over 2 is my only solution. So it's x equals to 3 pi over 2. So you do have to pay attention to your domain. Okay, let's look at number 9. All right, so number 9, I have 3 tangent squared u minus the square root of 3 tangent u. So here we can also actually factor out the greatest common factor. And here the greatest common factor is that they both have tangent in common. So I'm going to factor out a tangent from both of them. So it'll be tangent u times 3 tangent u minus the square root of 3 equals 0. All right, this tangent divided by a tangent, tangent squared divided by a tangent is tangent with the 3, and then these divide out to be 1, so it's just minus square root of 3. So again, zero product property. So I said both of them equal to 0. So tangent u equal to 0. And then 3 tangent minus the square root of 3 equals 0. So tangent u equals 0. So tangent, again, is y over x. So I want y to be 0 and x to be 1. Okay, and that happens at pi, right? My x value is 0. My y value is 1. Sorry, it's not just pi. It also could be 0. Sorry. So 0, an x value of 1 and a y value of 0 is at 0. But also at pi, I can have a 0 divided by -1 and still get 0. Okay, so 0 divided by -1 is still 0. And then also it could happen at 2 pi, right? 2 pi, it's 0, an x value of 1 and a y value of 0, which is what we want here. Okay, sorry for the confusion. Here I'm going to add the square root of 3 to the other side, so 3 tangent u, sorry, forgot that u. U is equal to the square root of 3. I divide by square root of 3, or divide by 3 on both sides. So tangent u equals the square root of 3 over 3. Now, if you think about it, this looks like someone multiplied by square root of 3 over the square root of 3. So what we're going to do is we're going to undo that by multiplying it again. Because on top, square root of 3 times the square root of 3 would just be 3. And at the bottom, I'm left with 3 square roots of 3. So those 3's cancel out. So I want tangent u to be 1 over the square root of 3. All right? And we kind of talked about this yesterday about how when 1 and square root of 3 are there, technically they're over 2 because I can divide those denominators out. So I want tangent u to be 1/2 over the square root of 3 over 2. Okay? And I want it to be positive, so they have to be the same sign. So I want angle where 1/2 and square root of 3 over 2. So y is 1/2 and x is square root of 3 over 2. So we're looking at u being pi over 6, right? Because at pi over 6, I have a x value of square root of 3 over 2 and a y value of 1/2. And then at 7 pi over 6. 7 pi over 6, they have a negative square root of 3 over 2 and a negative 1/2, but a negative divided by a negative is going to end up being a positive, which is what I want. Okay? But, so we have our 5 possibilities, pi, 0, 2 pi, and then pi over 6 and 7 pi over 6. But I want it to be between pi and 3 pi over 2. So if you look at your unit circle, pi to 3 pi over 2 is in quadrant 3. Right? So quadrant 3, the only is pi in quadrant 3. Yeah, so that's one of them. So my solutions are going to be, because these are brackets, meaning they're included. So 0 is going to include, or u is going to include pi. And then 0 is not, 2 pi is not, pi over 6 is not, 7 pi over 6 is. So my two solutions are pi and 7 pi over 6. All right, number 10. So number 10, I have sine x times secant x plus 2 square roots of 2 sine x equals 2 sine of x. Okay, so here I'm going to subtract a square root of 2 sine x because I want it to be equal to 0. So this is going to end up being sine x times secant x. And then 2 square root of 2 sine x minus the square root of 2 sine x is just going to be square root of 2 sine x, basically 2 minus 1, and it's going to equal 0. All right, so they both have a sign in common, so I'm going to factor out a sign. So sine of x times secant x plus the square root of 2 equals 0. So I want sine of x to equal 0, or secant x plus the square root of 2 to equal 0. Alright, so that's because of the 0 product property. So sine of x equal to 0, so I want the y value to be 0, and that's going to happen at 0, pi, and 2 pi. Right? At 0, the sign is 0. At pi, the sign is 0. And at 2 pi, the sign is 0. Okay? And then I'm going to subtract the square root of 2 here. So secant x equals negative square root of 2. Now, we talked about this yesterday about if I have a secant, I want to change that to its reciprocal, which is cosine. So here, the reciprocal of cosine would be, or the reciprocal of negative square root of 2 would be negative 1 over the square root of 2. And here, you want to get rid of that square root in the denominator, so you multiply by square root of 2 over square root of 2. So that would be negative square root of 2 over 2. So we want cosine x to equal negative square root of 2 over 2. And that happens at 3 pi over 4 and 5 pi over 4. Okay? But we have our domain from 0 to pi. So from 0 to pi, what are my solutions? Okay, so 0 to pi is the top half, so x is going to include 0, 3 pi over 4, and pi. So 2 pi is not included, 3 pi over 4 is, 5 pi over 4 is not. So I have 3 solutions there. Alright, let's look at number 11. So number 11, I'm going to add cosecant and subtract 7. So I'm going to subtract 7, and then I'm going to add cosecant to both sides, because I want this to be equal to 0. Now, cosecant squared and cosecant do not add up together because they're not like terms. So I'm just going to write them next to each other. So cosecant squared theta plus cosecant theta. And then 5 minus 7 would be negative 2. It's going to be equal to 0. All right. Now, here we're going to factor using either your box method or just if you know how to factor, then you can either use the box method or if you already know how to factor without it. Okay, so here, cosecant, I'm going to change cosecant to just be x. So x is equal to cosecant theta. Okay, so basically I have x squared plus x minus 2 equals 0. So I'm factoring this out. So you can use your box method. So x squared and negative 2. So I need 2 factors of negative 2 that add up to 1. So that's going to be positive 2x and negative 1x. So here x squared is x times x. What times x gives me 2x? That's a positive 2. And negative x times what gives me negative 1x? That'll be negative 1. So this factors out to be x plus 2 times x minus 1 equals to 0. Okay, but x is cosecant theta. So this is going to be cosecant theta plus 2 times cosecant theta minus 1. Okay, and because of the 0 product property, we set both of them equal to 0. So this is going to be cosecant theta equals negative 2 and cosecant theta equals positive 1. But we don't want cosecant. We want to change it to its reciprocal, which is sine. So sine theta has to be equal to negative 1/2, and sine theta has to equal, the reciprocal of 1 is just 1. Okay, so sine theta equals negative 1/2, so that's going to happen at 7 pi over 6 or 11 pi over 6. And then for sine theta to be positive 1, theta would be pi over 2. We want the y value to be 1. Okay, but let's look at our domain. Our domain is from 3 pi over 2 to 2 pi. So that is quadrant 4. So we have to make sure that these are in quadrant 4. 7 pi over 6 is not in quadrant 4. 11 pi over 6 is. Pi over 2 is not. So my only solution for number 11 would be theta is equal to 11 pi over 6. All right, let's go to the next one. Sorry. Number 12. Okay, number 12 I want you to try, and then I'm going to show the work right now. Okay? Pause the video to try it. Okay, so hopefully you tried it already. Here is the work. So 2x squared plus 3x minus 2 equals 0. I replaced sine of alpha to equal x, and so I made it 2x squared plus 3x minus 2 equals 0. So I came over here with the box method to factor it out. Remember, don't forget to multiply these down diagonally. So I need two factors of -4 that add up to 3, and that was 4 and -1. And then you figure out the outside. And so what I did is, instead of putting x plus 2, I replaced sine alpha back, sine alpha plus 2, and then 2 sine alpha minus 1. Now, sine alpha equal to -2. That is never going to happen, right? Our unit circle, the biggest it gets is a radius of 1. Okay, so the radius is 1. So that means the y value is never going to be -2. So that's impossible here. So it does not equal -2. But the next one I have is, if I set this equal to 0, it would be sine alpha equals +1/2. And that does happen at pi over 6 and 5 pi over 6. So that is possible. Okay. Go ahead and try number 13. Actually, let's skip number 13. We're going to skip number 13. Okay, let's look at number 14. Number 14 is tangent cubed y plus tangent squared y minus 3 tangent y minus 3 equals 0. So we're going to try to factor this by factoring by grouping. Okay, so we're going to split this. And what we're going to do is we're going to factor out a tangent squared here, which is the GCF. So you factor out the GCF. So this is tangent squared y. Okay, and so this is going to be tangent y plus 1. And then over here, the GCF is -3. So I'm going to factor out a -3. And that's going to be tangent y minus 1. Or plus 1, actually. Because if -3 divided by -3 is +1. Okay. Then they both have a GCF of tangent y plus 1. So I can factor that out. So tangent y plus 1 times tangent squared y minus 3 equals 0. Okay. And then we set both of these equal to 0. So I want tangent y to equal -1. And then tangent squared y to equal +3. Here, tangent y equal to -1. So again, we want, for tangent, it's sine over cosine, so that's y over x. So the two values have to be the same. It's just one is positive, one is negative. And so that happens at 3 pi over 4, right? Or 7 pi over 4. Okay. Now, tangent squared y equals to 3. Here I'm going to take the square root of both sides, right? So I have tangent y equals to plus or minus the square root of 3. So you have to split it up into your two cases. So tangent y equals the square root of 3, and tangent y equals negative square root of 3. Well, we talked about this one yesterday, about how tangent y is y over x, right? So it's the y value over the x value. But we don't have square root of 3 and 1. We actually have square root of 3 over 2 and 1 over 2, and negative square root of 3 over 2 and 1 over 2. Okay, and so now you can find these on your unit circle. So I want the x value to be 1/2 and the y value to be square root of 3 over 2. So x value of 1/2 and y value square root of 3 over 2. So that happens at pi over 3. But again, tangent is diagonal, so this could also be negative and negative. So that happens at 4 pi over 3. Okay. And then for negative square root of 3 over 2 over positive 1/2. So basically we want them to be like this. Either the top could be negative or the bottom could be negative. So that happens at, so that's going to be at 2 pi over 3. And then also diagonally down 5 pi over 3. Okay, so I have 6 possible solutions, but they just want me to worry about the top half from 0 to pi, right? So then I'm going to come off over here to write my solutions. So y is going to equal, I'm going to go one by one. So 3 pi over 4, it is in the top half. Okay, good. 7 pi over 4 is not. It's in quadrant 4. Pi over 3 is in quadrant 1, so that's good. 4 pi over 3 is not. It's in quadrant 3, so that's not good. 2 pi over 3 is in quadrant 2, and then 5 pi over 3 is in quadrant 4, so that one's not good. So I have 3 solutions. My 3 solutions are pi over 3, 2 pi over 3, and 3 pi over 4. Okay, so this is how you factor trig, or this is how you solve trig equations by factoring. Okay, if you have any questions, please ask me.